All right, hello again. We are on page 58, the last level of the first skill of Unit 8. And so multiplying and dividing radicals, I'm going to actually leave these as problems for you guys to do. I'm going to use the space down here to kind of go through how multiplying and dividing works. Okay, so when multiplying radicals, my advice, first of all, is to check if any radical breaks down or reduces first. For example, like just scanning this real quick, I don't see any that are obvious, okay? What I mean is, like if I have 4 square root of 9 times 2 root 3, right? You could certainly multiply the 9 and the 3 together first, but right here, the square root of 9, I know that that's 3. And so this becomes 4 times 3 times 2, and then the square root of 3 is just kind of left. And so now you would multiply the numbers that are not inside the radical together. 4 times 3 is 12, times 2 is 24. So this would be 24 root 3. Okay? So first you check if any radical reduces, and then you multiply coefficients together. So the numbers in front just get multiplied together. And if you still have other radicals, like let's say root 3 and root 5, then you can also multiply the radicands together. And then there is one final step, and that is check radicals for reducing. Okay, so first you're going to check to see if any radical reduces. Like this example, I had a root of 9, which turned into just 3. And so I didn't really have to do much except multiply the 4, the 3, and the 2 together. And then I was done. Now in a different scenario, like let's say I had, so this is first example, let's say I have 5 square root of, let's say, 8, and then times 2. Let's do square root of, I don't know, 6. Okay, so first I would check to see if any radical reduces. And look, even if you miss this opportunity, you can still figure it out at the end. So don't worry, and I'll even make that mistake right now. So the square root of 8, it's not a perfect square. So it's not like a nice answer like the square root of 9 was a 3, right? And the square root of 6 is not a perfect square. So you can't really do anything with that. So you can go ahead and proceed and go down to option 2, and then step number 2, and then step number 3. Now, if you don't catch this, it's not a big deal, but you could reduce the square root of 8 first. Okay, so I might even do it both ways so you can see, but let's just kind of stick with the obvious option, which is the square root of 8 does not turn into anything nice, and neither does the square root of 6. So now we're going to take 5 times 2, and that's going to be 10. The square root of 8 times the square root of 6. So you multiply the 8 and the 6, and you get 48. Okay, now we're going to break down 48. Okay, and so you're going to try to figure out, well, what reduces to 48? Or multiplies to 48. So we got 6 times 8. We got 2 times 3 is 6. 8 is 2 times 4. 4 is 2 times 2. So 2, 3, 2, 2, 2. Okay, so we got 1, 2 is one pair of 2's, another pair of 2's. So 2 2's come out, and we have a 3 on the inside. Now don't forget, we still have the 10 in front of there as well. Okay, so the square root of 48 turns into this, and we still have the 10 in front, so the final answer will be 10 times 2, which is 20, times 2, which is 40, so 40 square root of 3. Okay, now let's say you do it a slightly different way, like you see, oh, well, I know that if I break down the square root of 8, the square root of 8 is really 2 root 2. Okay, no big deal. So if we go this way, we got 5 times 2 times 2, so that's going to be 20. And then you got root 2 and root 6, which is root 12. Okay, notice these answers are not quite the same. Numerically, they equal the same value, but we have one last step to do, which is still always checking any radicals for reducing. And so root of 12, I'm going to continue right down here. Root of 12, if I split it up, I know that that's 2 root 3. Okay? And again, I'm kind of going faster through the reducing because now you should be more comfortable doing that. So if you need help with reducing the radicals, go back and review previous videos. And then 20 times 2, you get 40 times the square root of 3. So either way you do it, excuse me, either way you do it, you're going to get the same answer. Okay? So first step, check to see if any radical reduces. If it does, then go from there. And then what you do is multiply the regular numbers, the coefficients, so to speak, multiply all those together. And then any radicals you can multiply together. And then the final step is to reduce one more time. Okay? And then simplify. So that's kind of how you would do these 6 questions here, so you guys can try those. Now, as far as dividing goes, it's kind of similar. So my advice would be first, kind of like the first example, can you square root? Can you actually square root any? That'd be the first option. If not, then what I would suggest you do is reduce or divide the fractions. Okay? And so here's what I mean by that. Oh, and of course, step 3, reduce any radicals. Now, I don't believe we're going to be rationalizing quite yet. So this is just going to be basically these 3 steps. So here's an example. Let's say I have, the square root of 40 divided by, let's do square root of 4. Okay. And again, there's so many different ways to do some of these, because some of you might look at this and go, okay, well, I know that the square root of 4 is 2. And so I've done the first step. Next, right here where it says reduce or divide the fractions, this would be normal numbers, so coefficients only, or radicals only. Okay, you can't, for example, you can't, this is a great one right here, this 6 and that 6, you cannot divide those, okay? This 2 and this 2, you cannot divide those either. However, you can divide this 6 and 2 right here, because they're both inside of a radical. That's kind of what we're talking about. Okay. Anyway, continuing with this example. So, yes, I was able to square root 4. Great, so now I'm here. And now we're just going to reduce the radicals. So, square root of 40, I know that that's 2 root 10. either reduce it with option 1 or option 2. Again, review some of those previous videos if you're not sure how we're getting here. And then 2 divided by 2 cancels out, and so you just get root 10. Okay. Now, let's say again you kind of go out of order and you don't follow these steps necessarily. Here's the key. As long as you're reducing radicals, you're going to be all right. Okay. So let's say same example, root 40 over root of 4. Let's say I don't do it this way, but I go, you know what? The square root of 40 divided by the square root of 4, these are both inside of a radical, so I can actually divide those, and I get square root of 10. So actually in this case, kind of forgetting that was a little bit quicker. Okay, so either way, you get the same answer. Sometimes this will be quick, sometimes it won't. And unfortunately, there's no really, like this is always the fastest option. Okay, but these are essentially the steps you want to try. But the key is that you're always reducing any radicals. Okay, so for example, let's do 1 up here. Let's do number 11. Okay, so, and again, I'll try to do it a couple different ways so you can see that there's a few different ways to do these and you still get the same thing. All right, well, hey, 5 root 12, 2, and right here I see the square root of 100. I know that that's 10. So that's done. And now the square root of 12, that's going to get reduced. 2 times 10 is 20, by the way. The square root of 12, that reduces to 2 root 3. And so 5 times 2 is 10. And now we can still reduce this fraction. Since both of these numbers are outside of the radical, you can reduce that fraction. That's just 1/2. 10 divided by 20 is 1/2. So 1 root 3 over 2. Or just root 3 divided by 2. Okay? So that would be kind of the way I'd go about doing it. Now let's say you don't do it that way. Maybe you go this route. So 5 and 2 are reduced. But 12 over 100, that does reduce to something else, right? So if you think about that fraction, you get, I think, 3, 12 over 100. Divide everything by 4. This is going to be 3 over 25. And so you can reduce this root 12 over 100, okay, is the same as root 3 over root 25. You just keep the roots there, all right? And now you got 5, root 3 on top, 2, but then the square root of 25, the square root of 25 is 5. So we get 5 root 3 over 10, which, again, 5 over 10 is the same as 1/2, so it's going to be the same exact answer that we had the first time. Okay, so you can see here that both options kind of took a little bit to get to the same answer, but like I said, the key here is to always be reducing radicals along the way. Okay, and so that is essentially how you divide. We'll let you guys finish these up and we'll go on from here. All right, so thank you for listening and tuning in. We'll see you for the next skill.